Today I'm going to be presenting the case study of River X, which is the local catchment case study in AQA level geography in water and carbon. This is basically what the specification says. You need to know case study of a river catchment at a local scale and a bunch of things like the key themes of the carbon water cycle and their relationship to environmental change and human activity, and considering the impact of precipitation upon drainage basin stores and transfers and implications for suitable water supply and/or flooding, which we will cover today. So that was the background. The River X has many tributaries, meaning that it has a higher drainage density. So you can see in this image, all these blue, lighter blue lines are the tributaries which flow into the main river, which is this darker blue line. So topography is mainly highlands at Exmoor and Dunsmore, hence draining rainfall into the river with steep valley sides. 50% of the land, or the median, in the drainage basin is above 171 meters. 50% of the grass, there's 50% of grassland, which is less efficient in intercepting water. Mainly, this is used for just grazing land for cattle and other agricultural kind of reasons. There's 4.5% of the area is urban, so in places like Exeter. 13% is woodland, which is more efficient in holding water, which we will look at in, I think we mention it in the Amazon rainforest case study for why exactly woodlands are better, but it's mainly to do with how the trees are able to evapotranspirate the like water, and also there's the stem flow, so there's less water going to the actual ground and being intercepted and being like used as surface runoff, and more is actually put back into the atmosphere than just back into the river. So there's low permeability, there's 62%, which mainly is sandstone. So it's a very tough rock, and it doesn't allow for much water to percolate through it. There's only 3% of high permeability, and currently the flood risk for the there's approximately 11,000 properties at 1%, which means that it's the likelihood of a flood happening within a 1 year period. Which, if you ever see like where it says that there's flood risk for at 1% for amount of properties, it's the flood recurrence interval. It's also going to be in another case study that I'll be making a video on as well. So the drainage basin hydrological cycle system is a local open system, if you'd like to know. So some of the human activities, this is about peat bogs. So peatland restoration is done to return moorland to saturated boggy conditions to help them retain carbon in the peat. Exmoor peat bogs channels are man-made drainage ditches created to make land, and in the next slide we'll talk about why they were created. So this land is suitable for farming and grazing animals. They were drained for farming, and the peat bogs were used for pasture burning. When peat dries out, it releases carbon and methane. Draining channels increase the rate of water entering the X, because they can't hold the water if they're not a peat bog anymore, really. In addition to the amount of sediment or silt in the river, which if you load the river with too much sediment, it increases the flooding because it reduces the depth of the river. So it reduces how much water the actual river could hold. So something that they've tried to do, the Exmoor Myers project has tried to do, is to block these drainage ditches which have been formed, which were encouraged by farmers to dig after the World War to cut drainage ditches and to make land better for farming and cattle. So the project cost £2.2 million to cover 2,000 hectares. It slows down the flow of water across the landscape. So there's less flow equals less sediment. It makes the river cleaner, so cheaper to treat. It makes flooding less flashy, which means it responds slowly to floods, which allows recharge of river stores. It improves the carbon cycle because more carbon is stored in the peat bogs and less in the atmosphere. One thing that the project did was to block up the drainage ditches with wood, which was low cost. Water was still able to pass, but a lot less slowly, allowing more infiltration. Peatland restoration encourages sphagnum moss to grow on wet, boggy pools on the moor, which soaks a lot of water up like a sponge and can hold 20 times of its own weight. Holding a lot more water, so less goes to towns like Exeter, which hold more than a third of the water after restoration, releasing water more slowly to Exmoor streams and rivers. There has been a 2.2% rise in the water table and 110 meters cubed of water per hectare. So that just kind of says like how successful it's been. Some other human activities is the Wimbleball Reservoir. I love saying that. It's a very weird name. So in 1979, the tributary of Exe, the River Hadell, was dammed. 150 hectares in size. It supplies water to Exeter and East Devon and regulates the flow of water, which reduces steep peaks in the flood hydrograph and drought. So in terms of agriculture, the cattle compact the grassland, which makes the land less able to hold water. So the infiltration capacity is less. So that's one of the negatives. There are some relief channels also constructed. In Exeter, this is defined as a system of channels that carry excess water from the River Exe to the sea. An example would be the Trews Flood Relief Channel, which was a channel that was lowered to increase its flow capacity to reduce flood risk to the Quay area. And the water quality is better in Exe because there's less sediment, which saves money on treating water for drinking, which we've mentioned before as well. So I haven't found much for the River Exe, but here is a question. And that's it. Thank you.